All right, hey everybody, happy Tuesday, asynchronous class day. Now, what I'm giving you today is usually kind of the lesson that I do when we're doing the textbook a lot more normal school year, which is using substitution. So this is the first time that typically people will learn substitution in Algebra 1. If they hadn't done a little bit of substituting in eighth grade, they're doing it now. So anyways, this led in directly from something called an equal values method, which I usually teach. You don't need to worry about, though. It's fine. You can just do substitution, do for all problems, okay? Substitution, do it for all problems, and you're just getting some practice. You're going to do that substitution method problem of solving, okay? Problem of solving. So what I want to draw your attention to up here is that this is from the systems of equations chapter in your textbook. Now, we started doing systems with systems of inequalities, right? And constraints and finding feasible regions. What you're going to see now in the next few days of lessons, just as a heads up, we're going to be looking at more systems of equations, right? Equations here. So if you look up here, this is just kind of drawn here. So what we learned yesterday, what we tried to review yesterday, to find a solution using graphing is, like, for instance, these are two lines right here, right? To find the solution of these two lines, you could graph this line, y equals negative x minus 7, right? Y-intercept would be 0, negative 7. Slope would be negative 1. You guys could all graph that, right? This might be a little bit harder to graph. You could graph using the intercepts method, but whatever, you can graph them. Your solution, okay, your solution is the point of intersection, right? So this is your solution to a graph of systems, right? A graph of systems. So that's why when you get a solution to a system, you need your x value, you need your y value, right? And those are just the coordinates here. So if I look at this system right here, it looks like the solution to my system up here is 2, 1, right? 2, 1. So my solution to this system is 2, 1. Simple as that. Simple as that. Okay. So today we're not going to have graphs for us. So we're not going to be able to tell what the answer is. I don't even just eyeballing the graphs. It can be hard to see. Like, remember the one yesterday? It was like 4.95, 9.88 was like one of those solutions. But anyway, so sometimes it's going to be hard to see the graph, but if you can see it clearly, it's easy to come up with the solution. Look at that, 2, 1's the solution to that system. Today, we're not doing with graphs, we're doing just with solving, okay, which is sometimes easier because, again, if you get decimals, if your graph's messy, it just might be easier to solve a system by graphing, figuring out what values of x and y would work simultaneously in this equation and that equation. What's going to be the solution for both of these equations, not just one. Okay, so let's go ahead and jump into it. I'm not going to read this very top one right here. I'm not even really going to read this one right here because, again, what you're doing this whole lesson is you're solve by the substitution method, by substitution. And that's what we'll do now. So check it out. I got this right here. How am I going to solve this? Well, simple. Well, let's make this equation number 1. Right here, we'll make this equation number 2 right here. What I'm going to do, step 1, okay, if you're following along, I'm going a little more slowly because, oops, wait, I'm not set to record there. I don't like to do that. Let's do this here. Step 1, okay, what we want to do for step 1 is we want to take what y is equal to in equation number 1 and substitute that in for the y that we see here in equation number 2. Now, that was a 5 in front of this. I might have to get rid of this so you can see it more clearly. We're going to, right, step 1, substitute, right? Substitute what we know y equals, okay? Y equals, and we'll put that in a second lecture. Y equals this, right? So when you have a variable isolated, okay, variable isolated. So look at here. Y equals means y is isolated. What's the word isolate mean? Isolated means it's by itself. It's all alone, right? All alone. Okay, so what I can do is I can change this equation now. Equation number 2, step 1, we'll substitute what y equals into equation number 2. I can change it to this. 5 times by negative, oops, maybe I'll do that in green so you can actually see the substitution. Yeah, you want to see it. Negative x minus 7, and let me close parentheses. And I'm going to add 3x to it, right? Because I'm just instead of writing freaking y, I'm writing what y is equal to. Negative x minus 7, we're good to go. Then we got plus 3x, and that's equal to negative 13. So now this problem becomes a solving problem. Now, I know we haven't done solving too much this year, but they have been on homeworks. Emma's gotten some feedback on homework, so I've tried to write you feedback on homeworks semester number 1. So if you need help with solving, I'd love if you met with me during office hours. So I'd love to get you caught up and get you so that you can solve something like this really quickly. Anyways, how do you solve something like this? Well, step 1, we got to distribute. Check it out here. This parentheses, when you see parentheses, you must multiply. Parentheses in math means multiply. So you see a number outside of parentheses is grouped in here. That means I need to multiply this 5 by this negative x, and I need to multiply this 5 to this negative 7, okay? So if I have a negative 1x right here, and I want 5 more of those, that's going to end up being negative 5x afterwards, right? Negative 5, and then if there's nothing in front of this, that just means negative 1x right here. 5 times by negative 1 is negative 5, and then this negative 5x is what we're talking about here. 5 times by negative 7, well, a negative times a positive, right? 5 is positive, negative 7 is negative. Negative times a positive is a negative number, so I know that this product's going to be negative, but 5 times 7 is 35, so we got negative 35 here. Okay, add 3x to it, equal to negative 13. Okay, step 1 was to distribute as my first step here. Step 2 is going to be to combine like terms. Okay, so what I see here is I see that I have a negative 5x and I have a positive 3x right here, right? That's 3x's and then negative 5x's. Those are like terms, right? They have the same variable, same exponent. Okay, there's both x to the first power terms here. Anyways, combine like terms, right? Terms are separated by pluses and minuses. Anyways, there's lots of rules of math that you pick up through the years here. Okay, so negative 5x, add 3x to it. It's a little bit tricky for some folks here. I got a negative 5x. That's pretty far away from 0 on the number line, negative 5. 3 is closer to 0 on the number line. So I'm going to add 3 to it. So I'm moving up from negative 5 to closer to 0, right? Because I'm adding a positive number to a negative number. But ultimately, my sum is going to end up being negative because negative 5 is more negative than positive 3 is positive. So anyways, negative 3, and then I'm going to go up to negative 2. Okay, so I'm going to get negative 2x's I would have left, negative 2x. And then here I got this minus 35. I'll deal with that later. I don't need to worry about it too much. And then that's equal to negative 13. Okay, there we go. So that's it. I got negative 2x's here. I got negative 35. I got negative 13. Now I want to start simplifying this. Now that I combine like terms, I'm going to start moving things around with my equal sign right here, moving things around. So one thing that I need to get rid of, because again, right, substitution, which you should have seen before, we're trying to get a value of x, trying to get a value of y. Which one are we trying to get right now? We're trying to get x because we substituted an x expression in for what y was. So anyways, I'm trying to get x by itself. The thing that I tell people, if you struggle with solving, the thing I tell people is start simplifying and simplify away from the x, okay? Simplify away from the x. What I mean by that is this x here, we ultimately want to see what 1x is going to end up equaling. And this x here, you got to think about what happens to x in this here. If we knew what x, say x is 5, what would we do with it? Well, if x were 5, the first thing that would happen to it is that negative 2 would get multiplied to x. Negative 2 times 5 if it's 5. I don't know if it's 5. I don't know if it's 5. I have no idea. Okay, so negative 2 would get multiplied by x, and then 35 would get subtracted from that, right? The PEMDAS rules, negative 2 gets multiplied, and then subtractions later. When you solve, you kind of do reverse PEMDAS. So what I mean by reverse PEMDAS is let's do it the last thing that would happen to the x based on PEMDAS, which is this negative 35, and let's get rid of that as we simplify here. Okay, so this unit's kind of a bit of a review of solving, so hopefully you've done some of it before. So you're gonna have to get caught up, right? You have to get caught up and work with me here to kind of solve this one. Okay, so anyways, trying to pare this down, right? Simplify this down to figure out what x equals. I'm going to start away from the x. I'm going to try to get rid of this negative 35. And the way I can get rid of negative 35 is I can make it a 0, right? If I can replace negative 35 with 0, then it goes away, right? 0 is the absence of any value whatsoever. So that's what I'm going to do. I'm going to get rid of it right now. And if I have negative 35, what gets rid of negative 35? Well, I would add negative 35 to it. So 0 is here on the number line. Negative 35 is right here. If I add 35 to it, where am I? I'm at 0 on the number line. So I'm going to add 35 over here. I'm going to add 35 over here. So that's another thing too that you might not remember from the past. If I add one thing to one, so remember, this whole statement right here is a statement of equality. Okay, I know this because I rewrote this. I put the x expression in that y represented. I distributed. You're allowed to distribute. It's called the distributive property of multiplication over addition. So I know that negative 2x, I combine like terms, right? A lot of combine like terms. I know that negative 2x is minus 35 is here, and I know that's equal to negative 13, right? They're equal to each other. So if I add 35 to this side, I got to add 35 to that side, and my equation remains balanced, remains the same thing, okay? Add 35 to this side, got to add 35 to that side. Equation remains balanced, okay? So negative 35 plus 35, that's how I make a 0 on that side, and that's how I simplify this down. I end up with negative 2x, and that's equal to, well, negative 13 plus 35. Have your calculators out, guys. It's hard to make sure you guys are using your calculators. In a normal year, I require everybody to have calculators out because you're wasting everybody's time if you don't have it out, okay? Right? Go quickly so that we got this here, negative 13. You'll know how to use your calculator, right? We can work with one another on that. Negative 13 plus 35 is 22. So now I know that this here would simplify to be 22, and look at that. Negative 2 x's are here, and then we have positive 22 x's here. I want to get positive x right here. One thing you could do, one thing you are allowed to do is change this to 2x equal to negative 22 if you want to just make your life a little bit easier here, right? You can move that negative to the other side, or just, if this is negative and that's positive, then flip the both signs, okay? So the reason why you're actually allowed to do that is technically you're multiplying both sides by negative 1, okay, right? If you do one thing with this, is if these are equal and I make that one negative, I can make that one negative, and they're still going to be equal, right? That's something that you're allowed to do, okay? So that can make your life easier. Another thing you could have done to both sides here earlier in this step was just divide both sides by negative 2, okay? I broke it into 2 steps here, so I'm going to keep rolling with it. 2x equals to negative 22, so then the question is, what does 1x equal? What does this one have to be? 2 times by what equals negative 22? Well, negative 11, of course, right? Negative 11. So my answer here is going to be negative 11, but in order to isolate this, you can just divide both sides by 2, okay? 2x's here, divide both sides by 2. That's how I simplified down to get 1x. Negative 22 divided by 2, that's going to be negative 11. You can use a calculator if you want. That's fine. Okay, so there's one of my solutions of this system. I need to get the second solution. Okay, so step 2, this is what I've been showing you the past couple classes, or I guess just the one class that we had so far. Step 2, okay, solve for y. Okay, solve for y in the other equation, right? In the other equation. So really is substitute. Substitute in, solve for a variable. Step 2, right? Substitute again. Step 2, what you know for the quantity is for that one variable. Substitute in the other equation and then solve for that other variable. Okay, it's a pretty wordy out. This is why I don't have you write notes on it. It's better through examples rather than breaking out what exactly step 1 again, what exactly step 2, but just keep it in mind, right? And eventually you'll get it. Okay, x is negative 11. So what I'm going to do is I'm going to plug into this one up here. I'll plug into this equation. Y equals negative, and x is negative 11 minus 7, and that's going to help me get y. Right? There's my negative 11. I just plugged it in. Right? Plugged it into this right here where I saw x, and this is what I got here. So I'm going to get y equals the negative 11, that's positive 11 minus 7, that equals 4, right? That equals 4 here. Okay, so my solution is negative 11, 4. Okay, so that means on a graph, actually, the two lines would intersect each other at negative 11, 4. Okay, I want to see more of that, right, as the semester rolls along. Okay, so here's my answer. I would ideally write your answers as coordinates, like the way that I wrote it. Okay, that was confusing, right? That was confusing. The book breaks it down for you a little bit, step by step. So please do this problem too, right? So this is it. What you just did a second ago was a new method called the substitution method. It can help you solve these systems. As you notice here, we didn't have fractions, so you have to wonder like what came before this that have fractions. Anyways, substitution method, a great way to solve a question like this. Okay, if y equals negative 7 minus 7, then does negative x minus 7 equal y? Yes, the answer here is yes. And that is because of the symmetric property of equality. I don't you know what the symmetric property of equality is. Yes. And yeah, can you switch that here? Yes. All right, we can substitute equal values. Right? Substitute equal values with one another. That's sure. That's good too. I don't know. Weird question. Keep going on. B. Since you know that y equals negative x minus 7, can you replace the y in the second equation with negative x minus 7 from the top equation? Why or why not? Yes. Because y and negative x minus 7 they both represent the same quality, same quantity. Right? They're in an equation together after all. Y is the same thing as negative x minus 7. So sure, you can replace y with negative x minus 7. Sure, that's what equals means, right? Equals means equal quantities, right? So they can be replaced here. This substitution property of equality. Once you replace the y in the second equation with negative x minus 7, you have an equation with only one variable. Hooray, hooray, hooray. A couple people explains why that's good. Hooray. We get one variable here. We're able to solve it here. It's called substitution because you're substituting for replacing y with an expression that equals solve this new equation for x. and then use that result to find y in either of the original equation. So you could say I did this in question 431. Okay, do you need to do it again? No, I don't think so. Okay, but remember, you could check your answer. You could check your answer. What'd you get? You got negative 11.4. I got negative 11.4 in the top equation, so I can check it in my bottom equation here. 5y plus 3x equals negative 13, and I got negative 11 for the x here, and I got 4 for y. So hey, I'm just showing you you're allowed to change it, because I know that negative 11.4 works in this equation, works in the top equation, because that's how I got my answers. Negative, if x is a negative 11, then y would return a 4. And I'm just showing you that this is a system because negative 11 for x and 4 for y is going to work in the other equation if I've solved it correctly. Let's see here. 5 times 4 is 20 plus, oops, that's plus and minus. So here, this again, we're going to end up subtracting here because 3 times negative 11 is negative 33. So minus 33 equals negative 13, and it certainly does. Right? 20 minus 33, right? 33 is 13 bigger than 20. So if we're taking away a number that's 13 bigger, we get negative 13 as our answer. So here, negative 13 equals negative 13. So anyways, just wanted to show you that. If you're double checking that you did this right on a quiz or a test, that's how you check your answer to get it right. All right, 433, use the substitution method to solve the systems of equation below. So stay with me. We're going to do this quickly. Let's do this quickly, do this quickly. Remember, what is a system? System is a group of 2 equations. We got equation number 1, equation number 2, in case I need to reference which ones I'm talking about here. And they have the same variables in them. So sometimes you can find the common values that would make one equation true and the other equation true. It's the same values in both, right? The same values in both, okay? So what we're going to do here, substitution method, take 3x, substitute for y. We know what y is equal to. Get rid of it. Now we just have x in the equation. Okay, there's step 1. 2 times by 3x minus 5x equals 4. Distribute. Really, this is just multiplying. There's just one term right here. So this is 6x minus 5x equal to 4. 6x minus 5x is x. X equals 4. And here we go. Step 2. Step 2 is this. It's going to be plugged back into the other equation. X equals 4. So let's go ahead and plug into the easier guy right here. Y equals 3 times by 4, and I get 12. So I get 12. So my solution here, I'm going to write as a coordinates, because remember, this line here, that's certainly a line. Y equals 3x, so it's slope of 3. It's a direct variation line. No y, the y-intercept is 0, 0. So, and this is a line too, because we have x and y, no exponents with them there, and no other variables. So those 2 lines will cross each other at the point 4, 12. There we go, 4, 12. And that's that. Right, that's that. We can do a couple others. Let's do it, okay? Substitute for y. We're going in for y right here. So these can be pretty quick. Step 1, I'll get negative 5 times by x minus 4 plus 8x equaling 29. Negative 5x plus 20, right? Because I'm distributing in right there and right there. And then I got plus 8x equals 29. And here we go, combine like terms. I'm going to get 3x plus 20 equaling 29. Subtract 20 from both sides. You might be like, Mr. Fortin, this is way too fast. You do this for a living, you teach. Hey, you can rewatch it, right? Rewatch it, do the workout. Just check your answers with me, check your answers. Divide both sides by 3. That's how you isolate x. So just to remind you what I did here, okay? So I got x is 3, that's one of my answers. But I started simple, so I distributed. Combine like terms, right? Negative 5x plus 8x, right? 8x is bigger than negative 5 in terms of distance away from 0. We're further away in the positives than we are from the negatives, so our sum is going to be positive, so it's 3x. Okay, so once I have 3x plus 20, I simplify away from the x. What's further away from the x? The 3, should we deal with that first, or should we deal with the 20? What's further away from that? Deal with the 20. That's further away from the x. It doesn't touch the x the way that the 3 does. So subtract 20 from both sides, right? 29 minus 20 is 9. Now I can divide both sides by 3. Now I got x by itself here. 9 by 3 is 3, okay? And now I can use this to get what y's got to equal, okay? So I take 3 for x minus 4. That's going to equal y. So negative 1 equals y. And there's my answer right here. Write it as a coordinate. Is a great way to answer it. Systems question. We got that here. I think some of these ones get kind of interesting here. So let's see if there's some interesting answers here rather than just a pair of coordinates here. So let's get this. X equals 3 minus y. Plug in for x here. Okay, we got 2 times by 3 minus y plus 2y equals 18. And I'm going to distribute. We got 6 minus 2y plus 2y equals 18. And what's interesting, I remember this is interesting, this one. Look at this. Combined like terms, negative 2y plus 2y, that becomes a 0. And then all of a sudden I got this. What the heck? 6 equals 18? What? Question. Does 6 equal 18? That's weird. That's really weird. Okay, so your answer to this one is that there's no solution, empty set, no solution to this system. Okay, to C, there is no solution to that system. So the left side is a lot smaller than the right side. And that's true for the whole case here, right? 6 does not equal 18. So therefore, our answer is that we have no solutions to this. There's no values of x and y that will simultaneously work in the top equation as they do in the bottom equation, okay? So when you are eliminating stuff, when you eliminate the variable entirely, and you end up with an equation that's just false, right? Quantities that aren't actually equal to each other, and then the claim is that they're equal to each other, you'd say that, you know what, regardless of what x and y were, we wouldn't have been able to make them equal to each other because 6 is not 18. 6 is less than 18, so our answer is no solution to this system of equations. Let's try this one because there's another tricky scenario that comes in here. This is C, replace C. We end up with 3 negative b minus 11 plus 6 equals 6b. Negative 3b minus 33 plus 6 equals 6b. Okay, so this is tricky. We got variables on this side. We got variables on that side. What I'd like to do is collect my variables to one side. I'm going to add 3b to both sides. And the reason why I chose to get rid of this one is because this was negative. I want to get rid of it. I want to get my positives over here. That's going to make my life a little bit easier. Okay, we can combine these two. So I'll do that into the next line that I draw in. Negative 33 plus 6 is negative 27. 6b plus 3b is 9b. So we will get a solution for this one. We'll just divide both sides by 9. And we get negative 3 equal to b. So there's my b. And this one won't be that interesting of a one. It's just, see, this could either be no solution or all real numbers. We haven't seen all real numbers in a while here. So anyways, now I got to get c. So c is going to equal negative, and then b is negative. So I'll make that negative 3 minus 11. And c is going to equal 3 minus 11, which equals negative 8. Okay, so my answer here is negative 3. And I guess this is it because it's like, we don't know which one's the independent or dependent variable. I'll just do negative 3, negative 8, because that's the order that I did here, okay? They're relational, not dependent from one another. So anyways, so some vocabulary I learned recently. All right, so there's your answers there. There's your answer there. I got to see work, though. I got to see work when you're doing it. Okay, check this one out. So actually, here's what I was talking about earlier, is that this one was a no solution question. This is also going to be an interesting one. So let's take a look at it right now so we can hopefully get through this. 434, when Mai was solving the system of equations below, she got the solution x equals 4, y equals 2. Without solving the system for yourself, can you tell her where the solution is correct? How do you know? This actually isn't what I was thinking it was. It's not related to this no solution one at all. Yeah, it's probably going to be correct here because how can you, let's see, can you tell whether a solution is correct? Yes, I could plug in, or substitute is a better word. Substitute 4 for x and 2 for y to both equations. Okay, so to be a solution to a system of equations, you got to be true for both of the equations here, both equations, and see if they result in true statements rather than false statements. Like we had a false statement up here, so that means there were no solutions here. But if we take these, okay, and I take 4 times by, and x is 4, well, that's great if you show your work on this one here too, just to really show that you got it, plus 3, and then y is 2, and let's close parentheses, this equals 22. And then we're taking this one here, right? We took this one here, and now x is 4. Okay, and we're going to subtract 2y. And y, my friends, is 2. Why? For the love of God, why? And that equals 0. So this one, we can start with this one here. 4 minus 2 times 2, and that's 4, right? 4 minus 4, does that equal 0? Well, heck yeah. 4 minus 4 is 0. So we get 0, 0, check mark there. Okay, so here, that's not a negative, right? This is 4 times by x. So this is 16 plus 3 times 2 is 6. Does that equal 22? Well, yeah, 16 plus 6 does equal 22, so it works out. Okay, well, it works out. And they result in true solutions. And they do result in true solutions. And I have that as my proof right there, and I have this as my proof right there. For those of you who are doing geometry right there this year, you got to do lots of proofs. So algebraic proof, hey, I've just proven to you here. That's easy compared to your geometry proof. All right, wrapping up today's assignment. Well, if you watch this, you got it all done. Maybe you're trying it out afterwards. I don't know. I don't know how you're approaching it. 435, happy birthday. So we got a word problem. Wrapping up today's assignment. Let's do this. You've decided to give your best friend a bag of marbles for his birthday. Oh, that's so nice. That's a good gift here. Since you know that your friend likes green marbles better than red ones, interesting. Is this going to be an inequality one? I don't know. Better than red ones, the bag has twice as many green marbles as red. The label on the bag says it contains a total of 84 marbles. Interesting. How many green marbles are in the bag? Write an equation or system of equations for this problem. Then solve the problem using any method you choose. Be sure to check your answer when you are finished. Okay, one thing I don't like about this is that this question didn't ask you to define your variables. And you should always do that. My guess is that because they've had a lot of word problems in the book so far, and they've always asked you to define your variables, okay? That hasn't been the case for your Desmos assignments, but let's start with defining your variables, okay? So let's define some variables together. Let's see here. What are our variables going to be? It says how many green marbles are in the bag. So my guess is that our variables we're going to need, of course, definitely how many green marbles? Well, we can either have green marbles, or what's the other thing that might be changing this situation? Red marbles, okay? So I'm guessing that our variables are going to be green marbles and red marbles. So I'm going to let G equal the number of green marbles, and I'm going to let R equal the number of red marbles, okay? So this is a systems of equations problems. So using these two variables right here, we're gonna need to write at least 2 equations involving both these variables. How would they relate to each of one another? How can we write a systems of equality, right? Just equations of equality, more than one here. So let's go back and read it here. Read with maybe our pens here, right? Read with your pen if possible. If you have a book you can write in. But anyways, since you know your friend likes green marbles better than red ones, the bag has twice as many green marbles as red marbles. Okay, so we need equation 1 is going to be our sort of red to green equation. Right, let's see here, our green to red equation. Right, a green to red sort of relationship, and it's not a constraint, it's a statement of equality, so it'll be an equation right here, okay? So let's do it here. We got G is somehow going to be related total quantity-wise to R, right? So R here, and so it says here, green marbles better than red ones. The bag has twice as many green marbles than red, okay? So the question is, we got to ask ourselves, what's the bigger number here? What's going to end up being the bigger number? The green marbles we have twice as many green marbles as red. So green marbles, right? Green is bigger, right? Green is bigger, okay? So if we're trying to set up a statement of equality of green marbles and they're bigger than red marbles, the question is, which one will we have to multiply by 2? It says twice as many. So we're going to have to double one of them to make them equal to each other. Which one are we going to have to double? This is tricky. We're going to have to double the red amounts, right? The number of red marbles, we double it to equal the green marbles, because green marbles are twice as many as the red marbles. That's tricky for people to think through, right? I would, in your head, make sure this equation you write right now makes sense, okay? Say if I had 10 red marbles, how many green marbles would I have to have? Well, I have twice as many, so I'd have to have 20. 10 times 2 is 20, good to go. What if I had 50 red marbles? 50 times 2 is 100. Okay, cool. I think we've written this equation right, that based on the number of red marbles, we double it, and that tells us the green marbles right here. Okay, so there's equation number 1. That's the green to red sort of relationship. Okay, and the next thing they said is the label in the back says it contains a total of 84 marbles. Okay, so here we got equation number 2, and these are hard. Word problems are hard to come up with the equations here, but Equation number 2, typically, right, which you'll see in your textbook, which you'll see in the Desmos task that we have here, will typically have something called a total, something that I call at least, total quantity equation. Okay, so we came up with an equation relating the number of green marbles to red marbles. Now we need an equation that are relating the total quantity of them, right? Or just talking about the total quantity. Well, how much is the total quantity? 84. Okay, 84. How do we get 84 marbles? What do we do with our variables? Just add them together, right? Number of green marbles plus number of red marbles would equal 84. We know we have 84 total marbles together, okay? So this is total marbles, right? Total marbles is 84, okay? This is number of green. And we defined that earlier, G equal number of green marbles. This is number of red. So this statement should make sense, right? It should make sense after looking at it. Sometimes it's easier to have the teacher write the equations for you. Now you just have to worry about solving. So anyways, that's why it's usually a group work thing. You work through, you get it good to go. Okay, so now we need to solve this, right? We have equation number 1, equation number 2. G's isolated on the first one, so you know what that means by now. Let's replace G with 2R. Let's do it. Let's solve by substitution. Okay, let's solve by substitution. So we get 2R plus R equaling 84, and this is going to be really easy to solve. Combine like terms right here. We get 3R equaling 84. Divide both sides by 3. Again, you got your calculator out with you, right? You want to power through this really quickly. Like, save your brain space for the new stuff. Don't save it for don't use the old stuff with it. I know you like to do this in your head because you think it's faster, but no. There you go. Save it. It might be faster, but you'll make more mistakes. And you'll get tired. You won't be able to do the new stuff right here, okay? R equals 28 because I divided both sides by 3, isolated R. 84 divided by 3 is 28, right? What I say is do it in your calculator first and then check it in your head real quick. Does my answer make sense? Yeah, 28 times 3, it's a little over 75, right? 25 times 3 would be 75, a little bit higher. Yeah, checks out, all good. So we got that there, and we know that G equals 2R, so we need to do G equals 2 times by 28, and that's going to equal 56. That's going to equal 56 here. Okay, so our answer is here. Let's answer. We should answer as a statement here, right? How many green marbles are in the bag? Well, that's what they're asking. Okay, we need to produce the answer, and this is it. There are 56 green marbles in the bag. Okay, so I hope you have had as much fun doing this substitution assignment as I've had doing it, right? And doing it for you guys and hopefully laying it out kind of like how I would lay it out in class in a real deal, okay? Enjoy the rest of your Asynchronous Tuesday. This is all you have to listen to me today. I don't know exactly what we're doing on Wednesday. I'll figure that out. We're keeping through the unit. I think we got a couple more weeks left in this unit. Take care, guys. Email me if you have any questions. Stay strong. I will see you on Wednesday. Bye-bye now.